Okay, so last time we talked about electrolysis and how to predict what's going to happen. So here we need to evaluate how to do calculations for electrolysis. So let's review some terms, right? You know a joule is how we measure energy. And it's also, we can measure electrical energy with it, because a joule is considered a charge over a potential of 1 volt, meaning you can find the joules if you multiply the coulombs by the volts. Now, in case you're not familiar with this term coulombs is how we measure electrical charge. Remember Coulomb's law? Yeah? Okay, so, and volts is AKA, also known as potential. But I think I'm pretty much primarily going to refer to them as volts, because you use volts on your reductions chart, right? These are actually potentials, right? Okay, an electron has a charge of 1.6 times 10 to the negative 19th coulombs. So how many coulombs would there be in 1 mole of electrons? All right, so remember, if we're dealing about individual items, we're talking about moles, we should probably bring in Avogadro's number. So they're asking for coulombs. That's what they're asking for. So there are 6.02 times 10 to the 23rd electrons per a mole of electrons, right? So in 1 electron, there's 1.6022 times 10 to the 19th coulombs. So this is going to give us how many coulombs there are per mole of electrons. Which is 96,452. Okay, this number is going to come up over and over again. So this number here has a name. It's called a Faraday, right? And it's how much charge there is in a mole of electrons, right? Oftentimes it's rounded. A lot of times it's just, written as 96,500 coulombs per mole, or 96.5 kilocoulombs per mole, but you'll see it a bunch of different ways. You'll see the rounded form of it, and it's okay to do that. All right. Second term, amps or amperes. Amperes is the rate of current, rate of charge current, right? So amp is how many coulombs are delivered per second. Right? It's like the speed of charge delivery, you can think of it as. Okay. I threw this table in here just because it's a good reference, and it helps clarify, because you'll see, occasionally you'll see current terms. They'll mention your amps are this, but amps are really current, So when we say what is current, current is measured in amps. What is potential? Potential is volts. What is power? Power is measured in watts, right? 1 watt is joule per second. All of these terms are interconnected, and essentially you can use any combination of these to find the others. Just pay attention to the equations, okay? And these calculations are all kind of dimensional analysis based. So as long as you know what unit you're looking for, what unit you're canceling, you can find any value, okay? All right. But getting down to the chase of it, the reason why we need to cover this is because when we talk about electrolysis, we're often running a cell for a certain amount of time, and we need to get a certain mass. So time and mass are the main things we look for when we calculate with electrolysis. All right, so a car battery has a voltage of 12 volts. Suppose the battery furnishes a current of 10 amps for 15 minutes. Find the number of coulombs. So here we want to find charge. In order to find charge, it's useful to remember what each of these values means. Remember how an amp Amp is coulombs per second. So if they're asking for coulombs, this would be useful, right? The amps. And they're telling us the time. So do you see how if I have time and I have amps, I can find the charge? Okay, so if we stoke it out, 15 minutes, a minute, 60 seconds, and then there's 10 amps, so 10 coulombs per second. All right, that's important to realize how that goes here. All right, amp is a coulomb per second. Okay, so $9,000 coulombs. That's how much charge is provided. Now they're asking for the number of moles of electrons. All right. If only there was some relationship between charge and moles of electrons. Named after some dude whose last name begins with an F, who studied electricity. Yes, a Faraday. So if there's 9,000 coulombs, we can determine how many moles of electrons. So 96,452 coulombs per mole of electrons. So we're looking at 0.0933 moles of electrons. Okay. Electrical energy using the work formula. So remember how we said a joule is equal to the volts times the charge? We said that earlier. Right here. Volts times the charge. Okay. So a joule is actually derived from the work formula. To throw another variable at you, W is work, but work is measured in joules. So electricity gets confusing because of how many different, terms there are for essentially what are just a few things. All right. So that's, again, use this table as a reference. This just helps clarify things. So what's the how many joules are we talking about? Okay, so the potential. Did they give us the potential? The potential is the voltage. So 12 here, let's write it this way. Probably easier for you to see if we write it in terms of its derivative units. So volts are joules per coulomb. And so we already determined the amount of charge. We said it was 9,000. And so that's how we're going to determine the amount of electrical energy in joules. (108 kilojoules). All right, these equations, being able to calculate these things are important because when you eventually get to moles of electrons, by extension, you will be able to relate these moles of electrons to moles of a reactant or product, and thus you will be able to bridge it to grams. A very common question is, how long do I have to run something at a certain current to plate out 1 gram of gold onto this spoon, right? And so the basis is these calculations, right? And, individually they're small calculations, but the key is stringing them together to solve for the right thing. Okay, so let's try this. In the reduction of silver, 1 mole of electrons gives 1 mole of silver. 2 moles gives 2 moles of electrons gives 1 mole of copper. So why would that be? Remember, if you're reducing silver is a +1 charge. So all it would take is 1 mole of silver to reduce it. But in copper, it requires 2 moles because copper has a +2 charge, right? So the moles of electrons differs depending on what the charge is of the metal you're trying to reduce. So how much silver, and when they say how much, they're asking for grams, the mass. How much mass of silver is plated from silver nitrate solution if you have a current of 2.6 amps and you run it for 1 hour? Okay. Let's think about what we have. They want mass. They're telling us the current. They're telling us the time. Well, first of all, you know that your time has to be in seconds. Okay, so there's 3,600 seconds in an hour. How could we use that with amps? What do you know about an amp? Coulomb per second. So 2.6 coulombs per second. This gets us the amount of charge. Now I need to get from charge eventually to moles and grams of silver, but there's something that needs to bridge us there. I need to cancel coulombs. I need to get to moles of electrons. Faraday, yeah, right. So a mole of electrons is 96,452 coulombs. Okay, bless you. And we're talking about silver. So 1 mole of silver is sufficient. So 1 mole of electrons is sufficient for 1 mole of silver. And then a mole of Ag weighs 107.9 grams. We'll be able to plate 10.5 grams of silver if we let it run for 1 hour. And this is assuming that you don't run out of the aqueous solution. Okay. So using these relationships, use them to help you solve for mass, for the amount of time, for the amount of charge as we're electroplating. Okay, and we'll stop there today.